Hello, I welcome you all. The problem reads the 10 pounds box falls off the conveyor belt at 5 feet per second. If the coefficient of kinetic friction along AB is 0.2, determine the distance x when the box falls into the cut. This problem is coming from the Engineering Mechanics and Dynamics 14th edition by R.C. Hibbeler. So we have a box there that falls off the conveyor at 5 feet per second, and we've been given the coefficient of kinetic friction along AB. We have been asked to determine the distance x. Right, we're going to use the principle of work and energy. So what we're going to do is to find velocity VB. Okay, and with this velocity we'll be able to, because at this point acceleration from B to C would be due to gravity, so we need to use the kinematic equations, okay, from B to C to compute x. So we need a time from B to C, then later on use that time to compute this range x. Okay, so let's write down the equation for work and energy. So the initial kinetic energy for the box plus the total work done from point, let's call it initial kinetic energy at A, the total plus the total work done from A to B is equal to the kinetic energy at B. All right, so let's write down the equation. So we have the kinetic energy, and the kinetic energy is always positive, so we have VA squared plus the work. We have the work due to the weight as well as the work due to the friction. Okay, mind you, we have AB here, so we know that AB itself, AB by 3 the rise, right? AB by the rise over the hypotenuse is equal to 15. Okay, and therefore AB is just going to be equal to 15 by 5 divided by 3, which is just equal to 15 into 3 into 15 is 5, 5 by 5, this is 25. Okay, so that's AB. And then let's add more details here. So we do have the weight. We have the weight, and what else do we have? And then we do have this component there. We have this component for, we have this component, sorry. Okay, there we go, and also the other one like so. These are the components of weight. Okay, and then we have the normal force. All right, and then we do have another thing, which is the friction. Okay, we have friction. So let me just use this color here, use red. So we have the normal force, and then we have friction. So let's call this as Fk. Let's call this the normal force. Let's call this W. And then I'll be forced to find this angle. Again, you don't have to find this angle. You can use these triangles, this triangle, okay? But for case like this one, I prefer finding an angle, right? So you know that tan theta is just equal to, this is theta here, okay, is equal to 3 divided by 4 Therefore, tan inverse of this, I know this one is 36.87 degrees, right? I think so. 3 divided by 4, 3 divided by 4, tan inverse of that is 36.86987. There we go. So therefore, if this angle here is theta, this is 90 minus theta, therefore this one is going to be theta. Okay, so we know to say this one here is theta, therefore this one here is going to be theta, right? If that is the case, this just becomes W cos theta, and this one is W sin theta. So we will have work done here due to friction, okay, as well as work done due to the weight. Okay, is that fine? Great. So we have negative work. You've seen friction is in this direction like so, displacement in this direction. This one is giving negative work. And then we have the weight like so, and then the displacement also in this direction. This one is giving positive work. Okay, so let's write them down there. So we do have W times H, let's call it HA, okay, and then we do have minus FK by AB. And this is just equal to half MVB. Alright, so let's find what Fk is. So say summation of forces in the y equal to MAY, but we know that AY is just equal to 0. Therefore, we know that N minus W cos theta is just equal to 0. Therefore, our N is just equal to mg cos theta. And Fk is equal to mu k times N, which is just equal to 0.2 N, 0.2 mg cos theta. Alright, so let's plug in everything. And our VA is equal to our VA, we've been told, is just equal to 5 feet per second, and our W is equal to 10 pounds. Our HA is 15, and our AB is 25. Alright, so let's now write down the equation. So we do have half times M, which is just 10 divided by 32.2, times the velocity, which is 5 squared, and then we have plus W, which is just a 10 times HA, we said is equal to 15, then minus Fk is 0.2 by 10 cos 36.87, then times the length AB, which is the 25, right? And then this is equal to half times 10 divided by 32.2, okay, then times VB. So making VB itself subject to the formula, you can do this 0.5 by 10 divided by 32.2 by 5 squared plus 10 by 15 minus 0.2 by 25 by 10 cos 36.87 Okay, divided by 0.5 by 10 divided by 32.2. Alright, then square root of that. So let's start again. So we have 0.5 by 10 divided by 32.2 times 5 squared plus 10 by 15 minus 0.2 by 10 by 25 cos 36.87. Divided by 0.5 by 10 2.2. Then square root of that, we have 27.08. Alright, so this is our velocity here. Okay, so we are saying this is going to have components. It will have one component like so. It will have another component like so. Alright, and so we said this is our VB. This is our VB. So this one just becomes VB. I can use the triangle VB by 3 divided by 5, and then this one is VB 4 divided by 5. Alright, so here what we want to consider is we are not considering the whole lot of 30 meters because we don't have any dimensions down here. You see, look at this. The box, okay, has only been designated to fall up to point C. Of course, it will fall in the cut, but we've not been given the dimensions of the wheel and so on. So it means because the cut is elevated, it means it's going to fall where a little bit above the wheel, right? So the distance that we are going to consider when computing this will take into consideration the height of the cut and subtract it from the main height B itself. Okay, so basically what we are saying is we are going to consider this particular height from this point going this side. So it means even this height here will need to be considered, right? This one here, okay, this will need to be considered, and therefore this just becomes our HC. Okay, this is our HC, right? This is our HC, and then so we'll need to find the time it takes for the box to move from B to C, and at this particular point acceleration due to gravity will take over, right? So the acceleration is constant, so we need to find the time the box will fall from B to C. Then using that time we can compute X. So one of the formulas that we can employ here, it is this S is equal to S naught plus V naught T plus half ACT squared, and here we are going to look at, we'll start with the vertical motion. Okay, the vertical motion. So this, we'll pick this as our reference. So if that is the case, then S becomes equal to 0. Okay, and then S naught is going to be equal to HC, and HC is just equal to 30 minus 5, and this is equal to 25. And then V naught in our case here is going to be equal to minus VB 3 over 5, and this is just equal to minus 27.08. 27.08, times 3/5. Alright, and what else? And our AC is just equal to minus G, which is just equal to minus 32.2. Right, plugging everything in, then we'll have a 0 is just equal to 25, right? Okay, minus 27.08, 3/5, and then we have minus half, sorry, there's a t here, times t, then minus half 32.2 t squared. So writing this just becomes plus 0.5 by 32.2, 16.1, so minus 16.1 t squared, okay, minus 16.1 t squared minus 27.08 by 3 divided by 5. So this we have a 16.248 t and plus 25. So this quadratic, let's solve. We're just looking for the positive. Let's work on this one. I know you can do it even yourself. So square root there of minus 16.248 minus 4a, which is minus 16.1 by 25. Okay, so we are dividing everything like so, and then this is under the square root. Okay, so this is 2a, which is just a minus 16.1. Therefore, t is just going to be equal to minus 16.248, which is squared. This one here is squared. So 16.248 squared plus 4 by 16.1 by 25 square root of that. And then we have a 16.248 divided by like so. So this is the time it takes, 0.8398 0.8398 seconds. Okay, so this is the time it takes for the box to move from B to C. Let me check this again. 16.248 squared plus 4 by 16.1 by 25 square root of that. Alright, 83998. So once we find the time, we can now employ another equation, another kinematic equation, the same one but in the horizontal direction. So S naught plus V naught T plus half AC T squared. In the horizontal, we are considering horizontal motion. Okay, and horizontal motion here, the same reference, our S therefore just becomes equal to X, and then S naught becomes equal to 0, and then V naught is just equal to positive VB 4 divided by 5, which is just 27.08 by 4/5. And then we have AC just equal to 0. Therefore, our X is just going to be equal to, B node, which is 27.08 by 4 divided by 5 times T. Okay, so our T here, which is TBC, we said is equal to 0.8398. So this is the one we are plugging here. Okay, and therefore our X is just going to be equal to 27.08 by 4 divided by 5 times 0.8398. So our range is just equal to 18.19 feet. All right. So I guess we are done. We have found distance x where the box will fall into the cut. If you wanted to find this velocity here, okay, you can again use kinetic, you can use the work and energy principle. All right, from B, this point B here, or from A if you want. If you want from A, you consider the whole distance 15 and HC, but then you need to take into account the effect of work done by friction. To make it simpler, you can just consider from B to C because you already have VB. Then use principle of work and energy here, work done due to the weight, and then later on we can work it out here so that you find the final velocity at C. But that was not part of the question. Those are things that you can do on your own. So I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and I'll see you in my next screencast.